Well, good afternoon, everybody. Welcome to the third last seminar for the year for the CoE seminar series. I would like to acknowledge that this meeting is being hosted on the traditional lands of the Bindal people and pay my respect to elders, both past and present. Our expectation is that interactions during seminars are constructive and that all attendees behave with respect and consideration for others. Thanks very much. I will now pass over to Tiffany Morrison to introduce our speaker for the day. Thanks, Tiff.
Hi, everyone. It's my pleasure to introduce Paris Stefanoudis, who is talking today on turning the tide in parachute science, which is part of a series of talks that the Centre is running over the next few weeks on co-production ethics and diversity in research. I first met Paris last year virtually in the middle of the pandemic. And I managed to work with him on this particular paper. Well, I have to say he did most of the work that he's talking about today. Paris is a senior postdoctoral researcher at the University of Oxford and also working with the UK-based NGO Necton. His research, as you can probably guess, has a marine biodiversity and conservation focus, and he has worked on projects in the high seas, Bermuda, the Seychelles, Comoros, and the wider Western Indian Ocean region. He has a lot of experience working with different nations to ensure research is co-designed and co-produced in order to benefit all parties involved and produce policy relevant outcomes. And he's also passionate about raising ocean awareness through various media, including BBC World and other public outreach and training programs such as Oxford Sparks. So thank you, Paris, for talking today. I'm aware it's very early where you are. And hopefully we can talk for about 40 minutes and then we'll open up to the floor for some vigorous discussion afterwards about what this all means for the way we do our research. Thanks, Paris.
Thanks for the introduction, Tiffany, and thank you for inviting me. Is my sound and presentation mode okay? Yeah, all good. So, hi everyone. I'm going to be just starting a little bit unconventionally with a short video where one of the co-authors of the paper, and my colleague Talma, briefly talks about what parachute science is.
Parachute science is a practice whereby international scientists or researchers go to a different country for their data collection or fieldwork, and in the process neglect to meaningfully include scientists from that country or that nation. This is not just with regards to publication, but also with regards to building skills within that specific research field.
It creates a dependency on external expertise, does not address host country research needs, and hinders local research efforts. The legacy of parachute science in a lower income country can and does make the work of local scientists like myself more difficult.
I'm not really 100% sure if that, if you heard that well. So I'm just going to sort of say those definitions again. I mean, we sort of define parachute science as the practice whereby you have international scientists, typically from wealthier nations, going and conducting research in other nations, typically lower income nations, which we call host nations. And then after collection of the data, usually there's very little engagement before, during, and especially after collection of the data. So there is not effective communication engagement with host nation scientists, and it creates all sorts of different problems, which I'm going to elaborate a little bit later on. So parachute science, some of you might have come across other terms such as colonial science or parasitic science or helicopter science, and essentially they all sort of describe the same thing. Is usually you have, as I said before, wealthier sort of scientists conducting international collaborations with scientists from low income nations, and usually there's very little engagement and communication throughout the duration of a project. So the sorts of problems it creates, I think Wilfredo already mentioned some on the video, but I'm going to just give a little bit more detail here. First of all, it creates dependency on external expertise. And what we mean by that is if there is no meaningful collaboration and knowledge exchange between foreign and local researchers, there are very few opportunities for different skills to develop. So therefore, host nation scientists at the end of the project will still remain dependent on foreign expertise if those skills were not developed. It also does not address local research needs because in many occasions, if there is no engagement before or during the project about what questions are of most relevance to host nation researchers, it might be just because something is interesting to the international collaborators. So a lot of the data sets that will come out of such a project will not be applicable or that relevant, if you like, to the researchers, working on the ground. It actively hinders local research efforts. And the reason for that being is if no skills are developed or no leadership opportunities are being given during international collaboration, that means that very few host nation scientists get to lead publications, they get to lead specific parts of a project. So when it comes to applying for funding later on, they will not have necessarily as strong a CV just because they have been excluded from those opportunities. So it actually hinders local research efforts. And all of these create a lack of trust between host nation scientists and foreign researchers who often view foreign researchers as exploitative when they come and want to conduct a project there. And a final point is that engaging in those sorts of practices does not only disadvantage host nation scientists, it also disadvantages the international researchers as well, because they're excluded from a wealth of knowledge that resides in host nation countries. They have been there for centuries. They know their areas much better than the international experts. So by not effectively communicating and engaging and working together throughout a project, essentially you produce also worse science at the end of it. So where does parachute science occur? It occurs, it's not unique to marine science, which is the focus of this talk. It occurs across many different disciplines. Here you can see some examples of where it has been sort of mentioned again. And just a very sort of typical example is in global health research. For example, what happens usually there, imagine an outbreak of a virus, which most of you can now with COVID. For example, the Ebola outbreak in Western Africa, or like the Zika outbreak in Brazil. And what happened in some occasions there is that researchers from wealthier nations, they sort of parachuted into the country, they collected patient data or genetic sequences of the virus, and then they went back to their home country. They developed a treatment, and at the end of it, sold that treatment back to the very same populations that are mostly affected by the virus outbreak, usually at very unaffordable prices. So this is a very sort of apt example of parachute science, which has been called out in the past. And the focus of this talk is marine science, specifically coral reefs. I'm pretty sure everyone is aware about coral reefs, but very briefly, their warm water coral reefs are found throughout the tropics and the subtropics. They hold about 25% of all marine diversity, and they are really important to humanity as a whole because they do provide a range of services for billions worldwide. Now, because there have been such hotspots of marine biodiversity over the, for generations, marine scientists have been fascinated by these ecosystems, and they have been studying them. I myself as well. So, this particular sort of field was is where a lot of parachute science might have been happening in the past, and we were sort of aware of this anecdotally and there have been papers maybe like in the past sort of describing these unfair or unjust research practices, but there wasn't necessarily a number behind it. So back in 2020, myself and other co-authors, including Tiffany that just introduced me, so we sort of thought that it would be very interesting to try and actually quantify how much of parachute science is actually happening in coral reef research. So we did that using, we wanted to sort of refer to the whole field of marine science as a whole, but we used coral reef biodiversity research as a proxy for that. And then we did a global analysis of articles using the Scopus database. So we looked at articles that have been published over the last 50 years. And then we used publication-related metrics, such as the order of authors, or like if authors from one nation were included or excluded, as a proxy of parachute science, as a proxy of effective communication or engagement, if you like. So what we found was that at a global scale, if you look at on the left, you have the top 10 nations in terms of research efforts, so the number of publications, and you can see that from those 10, only 2, and that was Mexico and Indonesia, they were not high-income nations, and actually 2 of them, Canada and Germany, they're featuring the top 10, even though they don't necessarily have coral reefs in their exclusive economic zone. So what that shows you is not that necessarily parachute science is taking place, but it just shows you that it's an environment that occurs throughout the tropics, for example, but there is sort of Western intellectual dominance on this field. And you see there is also a mismatch between research effort on the left and then actual coral reef habitat area on the right. So the top 10 nations that have most coral reefs in their waters, only Australia and Indonesia are actually featuring the top 10 in terms of research effort, while all the other ones, they don't produce as much research, which again goes back to the, so there is a sort of Western sort of dominance in terms of a habitat that sort of affects mostly people living in the tropics and subtropics. Jumping to another paper now, because it sort of puts more information to those previous 2 graphs, is a paper that was published a couple of weeks, maybe months ago now, I think. So they were trying to see, so they were also looking at authorship patterns of coral reef science. And I guess, in the previous graph, we saw the top 10 nations in terms of coral reef research, but we didn't have the information of where they were actually conducting the research. So this graph is giving information of where those scientists are conducting that research. So on the left, you have the institutional affiliation of the author, and on the right, you have where that study was conducted, and each line represents a different paper. So you can see that scientists, for example, from the United States or Europe and Central Asia and Australia, they tend to conduct research in regions other than their own, also like including their own, but also other regions as well. While researchers from other regions, they tend to do work usually within their own region, so they don't do research in another region. So back to our work. So after we looked at global patterns of research effort across coral reef biodiversity, then we decided to focus specifically on 3 countries in order to try and get some more nuance behind those numbers. So we focused on Indonesia, Australia, and Philippines, and the reason for that is because they are the top 3 nations in terms of available coral reef habitat. And what we found was, and then we color-coded all the publications from the 1970s all the way up to 2020, and we used black color when in that publication no host nation scientists were included. In that occasion, for example, what I mean by that is if that paper was having fieldwork conducted in Indonesia and no one from in the authorship was from Indonesia, that was regarded as that host nation scientists were actively excluded. So that would have been color coded with black. And then if host nation scientists were included, but they were not the last or senior author, but they were somewhere in the middle, that was color coded with blue. And then with pink, it's when they were leading the paper, which we regarded as being the first or senior author or the corresponding author. And then when you have yellow is when all the actual scientists in that paper were from that host nation. So in a way, no parachute science could take place in that occasion because everyone was from the host nation. So what we found in Indonesia and the Philippines was that about 40% of publications had no host nation scientists excluded, which is a sign of parachute science. While that, in Australia, that number was only was 20%. So it was about twice as low. And then when it comes to research leadership, so if authors were the first or the last author in a paper, it was about 30 to 40% in the case of Indonesia and the Philippines, and it was higher in Australia. And the reason why we sort of comparing always Indonesia and the Philippines versus Australia is because they do represent, they belong to different sort of income categories according to the World Bank. So you have Indonesia and the Philippines being lower to middle income nations, and then you have Australia, a high income nation. And then we also looked at research permits. Now, most of you are aware, but if you want to conduct any sort of survey in waters of a country, and if you want to also collect biological specimens or any other samples, you have to have a permit in place, as well as an ethics approval as well. So we sort of checked how many papers actually did specifically mention a research permit, and it was only 10 to 25%, with the numbers being low in general for all three countries, but they were definitely much lower for Indonesia and the Philippines. Now, not having a research permit explicitly mentioned in a paper does not necessarily mean that partial science practices were taking place. But when we discussed it between co-authors, we were certainly aware of occasions where, probably more in the past rather than now, this might have been the case in at least some of the papers, but it was very difficult to quantify. So this is more like a comment rather than an indication of actual parachute science taking place. So combining all these information together, we believe that the extent of parachute science is prevalent across all nations, but it's more common when that nation is a lower to middle income nation compared to a high income nation like Australia. It's still present. It's getting better, as you can see, for example, like black. If you see like the color on the bar charts on the right hand side, it decreases over time, but it's still present. Research leadership is still sort of relatively low, still in Philippines and Indonesia, but things are getting better, but it's still present. I'm a deep sea researcher as well, sort of focusing on habitats below 200 meters depth. So I was also interested to try and see, after like that work in coral reef research, is that the same case for deep sea research? Deep sea research in a way is even more costly, and it's very difficult to conduct deep sea research, and because it's also logistically and financially very complex. So it's probably an area where parachute science could be taking place. So looking at past oceanographic expedition gives you a good indication, at least, on which nations are dominating this field. And as you would imagine, it's typically high income nations like Britain, Germany, the USA. And this this table here shows the major oceanographic expeditions that happened from the late 19th century all the way up to 1960. And then, of course, you have the former Russian Federation back then. And over the last 30 years, because that was going all the way up to the 1960s, from the 1990s and onwards, again, this was a paper published 1 year ago, last year. And here it shows you research efforts for deep sea related publications. And you can see again that Europe is dominating all the research outputs, and then the United States and other nations are following, like Japan, Australia, or Canada. Again, I would like to stress that this does not, again, mean necessarily that you have parachute science taking place, because there might very well have been a deep sea related study in the waters of the UK conducted by UK scientists. But it would be interesting to try and put more nuance to those publications as well, to try and understand if you had, again, sort of exclusion of host nation scientists. So something for the future, perhaps. And finally, with the results, before I move on to some of the conclusions, is again this paper that was published a couple of weeks ago, which puts another dimension. So we looked at authorship patterns in terms of institutional affiliation. They were looking also in terms of gender. So they found that there was a great gender inequality in coral reef science as well. So they looked at papers from 2003 all the way to 2018, covering sort of 16 years. And they found that contribution from men was much higher than women. It sort of increased for women from about 18% all the up to 33%. So the situation is getting better. But they projected that at this rate, complete sort of gender balance in terms of authorship will be achieved in 2036. So things are getting better, but we also still have a long way to go. So what does this all mean, I guess? So you're all aware of the United Nations Decade of Ocean Science, and the mission statement is that, it includes building capacity, developing scientific knowledge, or sharing infrastructure and doing partnerships between all nations in order to achieve a healthy and sustainable ocean. And we believe that this will only be achieved if we adopt a research culture that is more ethical, and is more equitable, and where partnerships are truly collaborative. So this must, from our point of view, this must exclude the practices of parachute science. So how can we stop parachute science? And these are some of the recommendations we made in the paper, but I'm pretty sure there are many more. And these are just sort of some sort of high-level recommendations that we made. First of all is finding academic collaborators, which sounds pretty obvious, but it's first of all start with host country institutions that have if you're planning to conduct research in another location, start with identifying those scientists that are relevant to your work. You can use online databases to do that, to see who has been publishing in that field. But also looking at articles published in host nation journals, which sometimes have a lot of the leading scientists publishing there. It's also very important to liaise with the government and other funding bodies of the host nation, so they will be able to connect you with the most relevant individuals very often. The most important point probably for me is develop a joint research agenda. So once you identified some of the potential collaborators and you have been in touch with local government, it's try and have an extensive consultation with those scientists and those government officials to try and understand what is most needed for the location you want to conduct research on, and try and co-develop a joint research agenda. Another point that I feel very strongly about, being almost an early career researcher, I guess still, is try and engage with the next generation of researchers. This is really important because by doing that, so for example, by establishing exchange programs where students from the host nation or country might come and visit your lab and spend a couple of months there, and develop some, they get trained, develop some skills. This will eventually build the future, the leaders of tomorrow. So this is really important for marine science in general. And also both parties will benefit from it, because in a lot of occasions, there is a lot of knowledge in those host nation scientists. So it's a two-way process in terms of exchanging information. Share academic literature. You are all aware that for the very high fees of accessing literature, so a lot of people from the global south, they do not necessarily have access to a lot of the academic literature. So if you're working with host nation scientists that don't necessarily have access to them, share your academic literature. It's very simple steps, but this might go a long way in order to try and enhance access to information. Know the regulatory landscape. So many countries have very specific research teams for which they have very specific rules of what you can collect or not. So regulatory bodies and agencies in the country will help you sort of navigate your application when you do it. And finally, many institutions also, they do require a very better host country engagement as part of the research ethic approval. And finally, transparency in publishing. So most journals, as you saw with the permit number, they don't necessarily require that information to be part of the paper. It's getting a bit better now. Some journals make it mandatory, but we feel that much like most biomedical journals, they do require you to have a research permit in place if you involve studies with that involve animals, for example. It should be the same thing with any marine-based study that includes fieldwork or collection of biological specimens. Now, these recommendations were particularly addressed to scientists conducting international researches as well as publishers, but there are, of course, other players that have to do their bit in order to eradicate parachute science. So academia and research institutions in general, they're also part of this. For example, one common complaint that sometimes I hear from sort of scientists in higher income nations is that they do have the willingness to engage with host nation scientists during a project, but sometimes there are very limited funds, or there isn't enough time in their projects to actually do that. So it's not necessarily that there is a bad sort of intention, but it's just the reality of the modern sort of funding of a project that does not allow them to do this. So we feel that academic institutions value more sort of first and last author papers. They don't necessarily put as much emphasis on true engagement and collaboration with host nation scientists, and that should change. So, for example, if you have promotion committees in universities, we argue that it should not just focus on how many papers you've published over the last year, or if you have been necessarily the first or last author. So being a middle author, as long as you can provide sufficient evidence that you've done a lot of work, should be as much valuable as being the first or last author. So all these should be taken into account when reviewing someone's CV, for example, in order to get a promotion, because ultimately you have to incentivize and you have to recognize researchers that actually take time and they try to engage in fair research practices rather than penalizing them for actually doing that. And of course, research funders as well. A lot of the recommendations for academia is applied to research funders as well. I think research funders should make sure that if there is an international project in place, they should make sure that there are specific budgets allocated, specific funds in the budget allocated to those types of activities that promote truly collaborative science. And that could include anything from establishing mentoring programs. It could be conducting workshops or training within the host nation country. It could be in the form of webinars, now that we live a lot in the online world. So anything that sort of promotes true science. So they should also ask researchers that do conduct international research to actually have specific funds in place for that. And they should ideally as well, when they're reviewing applications they should also place as much emphasis on those type of activities as publications in high impact journals. And finally, the ethics committees. I think it's becoming pretty standard now that when you conduct research in another location, you have to have an ethics approval in place. But it should become the norm in cases it is not. And at the very minimum, there should be also a code of ethics at every institution or research institution where researchers working for that institution or university, they should adhere to the code of ethics. So it's becoming more common now to have at least a code of ethics for research. And finally, who else can do something? It's us, it's you, it's every one of us individually. We have to try and educate ourselves. I think it's really good that over the last 1 to 2 years, maybe perhaps being in lockdown made us reflect a little bit on how we work. This is certainly how we sort of came up with this work. So it's really important to have those kinds of discussions. So I'm really glad that we're having talks like this today, where we try to sort of think about how we've done research in the past and how we can make it better. So it's all about educating ourselves and try to make research collaborations better. Some sort of additional comments in terms of someone conducting research in another location where, for example, English is not the first language, is try and think about all those non-English papers that might be really useful to your work. So modern sort of day science gets dominated by English, but there are a lot of papers in other languages as well. And collaborating with host nation researchers whose native language is maybe not English might help you, accessing all that information that just sit there in Spanish or Russian or in any other language. And I think as well, embracing non-written information as well. So we tend to sort of focus a lot on peer-reviewed papers, but there is a lot of information, oral information or information that you can in art or storytelling that sits with a lot of marine professionals in other locations. So starting those discussions, try and see what other information exists other than written might also be relevant sometimes in your line of work. And because it sort of all sounded a bit doom and gloom, I'm just going to finish the presentation by having 4 examples where actually, you know, it was really, the case was that there was a really successful collaborative project between local and international scientists. I'm going to start with the Aldabra Cleanup project. So that was, that took place in 2018 and 2019. And it was a collaboration between the Seychelles Island Foundation and the University of Oxford. And what they tried to do is they were trying to clean Aldabra, a World Heritage Site, from the tons and tons of plastic and other types of litter that were washing up on its shores. So you can see on the graph on the right that they did actually involve this 5-step process where collaboratively they tried to find funding for it. Then they actually did the research. They did a lot of education artwork. So they really did excellent work also with engagement with the public. So they had interviews and other sorts of short films with Sky News and other media outlets. So they really educated people and made them aware of the issue of you know, plastic and other types of litter washing up on remote atolls. And then finally, they did actually clean up the island. So they managed to collect more than 25 tons of litter over the course of 2 weeks. That made headlines all over the news. So this was, and because I personally know people that have been involved in this project, they all sort of felt that it was a really good example of where international collaborations, you know, was really well, and both parties benefited from it. This is another example of a paper published this year, and this shows collaboration between researchers from a US university with indigenous communities. So the really nice thing about this paper is that they explained in the paper how they engaged from the very beginning with indigenous communities in order to try and understand what is the link between sea ice coverage and availability of seals, which is what they hunt usually in order to sustain themselves. So that was from the very beginning, both of the questions were put together on the table by both parties. And at the end of it, based on their findings, they had some recommendations of what should be done. And by doing that, so having like a meaningful collaboration throughout all of the stages of the project, it's also much more likely that any recommendations coming out of it, they're going to be accepted by the local community, because the local community, the indigenous communities, they were part of the project from the very get-go. Another example that I was involved with was the first Ascent Seychelles expedition. So it happened in 2019. And throughout this project, which is almost finishing now, we tried to engage as much as we could with host nation scientists. So we had workshops before the actual expedition, a couple of at least 6 months before the expedition. And then during the expedition, we also had a lot of host nation scientists involved in the sampling of the data, and then post-expedition, the data analysis, writing papers. So that was all done collaboratively. So we co-wrote together with some of the people from Seychelles our experience from that. Of course, we did not get everything right. This is not me trying to advertise that we were the best. We did get things wrong as well, but we felt it's really important to sort of capture some of our experiences so that maybe future researchers conducting research in another location could take them into account. And another final project, and then I'm done, I promise, is the My Deep Sea, My Backyard project. So this particular project it focuses on lower income nations, and it tries to use high-tech, low-cost technology, which is being currently developed in the United States in order to be able to access deep sea habitats, which are usually, as I showed you a couple of slides ago, it's usually being conducted by wealthier nations. So there were two projects, one in the Republic of Kiribati and now one in Trinidad and Tobago. And it was a really nice example where, again, you had researchers from the US collaborating with researchers from those nations, and it was a really positive outcome at the end of it. And just a final quote from our science program manager, Sheena Talma, who is also co-author of the paper that I was talking about today, is that parachute science is complex, it's multi-layered, and it's historical. The solution is not only about including more local scientists in publications, but about building relationships, developing knowledge exchange activities, and having mutual trust and respect between all parties. Local scientists have a lot to offer to foreign researchers, and building those partnerships enables skill sharing, empowers people on the ground to continue the work once the foreign scientists leave. And I think with that, I will, at the end of my presentation. Thank you for listening.